And welcome everybody. This video is going to go over functions in table format and how to evaluate a function given in table format and how to solve a function equation in table format. I guess I should say on that previous one, if we're evaluating a function for a given value, when that function is given in table format, how do we find that output? And then we're solving an equation of a function where the function is defined in table format. How do we find the input for that given output? So this is pretty straightforward here. Let's look at this first example, number 1. Let h of x be completely defined via the following table. So the way this works is the first column is our input values, our x values, and h of x is our output values. These we could say, it's not said that the output variable is y, but that's usually what we use here. So we'll say that this second column is h of x equals the output value, the y value. So if x is -1 in this first row here, then the output is 2.8. h of -1 equals 2.8 is what this is saying. The second row says that when x is 0, h of that x value is 9.1. That's saying h of 0 equals 9.1, and so on and so forth. The third row says that when x is 1, if I plug 1 into h, then the output is 0.1. If x is 2 in the fourth row, h of 2, the output should be -1.4. And then if x is 3, and we plug that into the function, the output should be 9.4. Let's note that this is completely defining the function. That's saying that there's no outputs for any x values outside of these 5 shown here. So x is -1, 0, 1, 2, and 3. Those are the only inputs that work. In fact, this isn't asked, but let's just note that the domain of this function is -1, 0, 1, 2, and 3. None of the numbers in between these numbers are part of that domain. Those are the only inputs that work for this function. So if we want to evaluate the following expressions, h of 2, then the output should be -1.4. That's coming from that fourth row there. If we plug in -1 into the function, we see from the first row, let's overlap that. That's better. If I plug in -1, we should get out 2.8. Okay, and so then we get down to part III here, part 3, h of 5. And this, we say, is undefined. If I plug in 5, the function doesn't have an output for the number 5. The number 5 is not something that this function knows how to handle. This function is only defined when the input is -1, 0, 1, 2, or 3, nowhere else. So this undefined we use if there's no output for a given function. So use this when a function has no output for a given input. Right? This is different than saying there's no solutions, which is the opposite, right? If we're given an output and there is no input, that's saying there's no solutions to the equation. We would not use undefined there. There we would say no solution. So depending on whether we're given inputs and looking for outputs or given outputs and looking for inputs, we use different language to give distinction between the two scenarios. Just like we give different words for different things in all parts of our lives, right? We need different words and different ways of describing things that are different from each other so that we can communicate about them in a meaningful way. So that's why we use different words for different situations. All right, part B says to solve the following equations. The first one being h of x equals 9.4. So I look to the table and I note that 9.4 is right here as an output. So I say, okay, what input gives me that output? And we see that 3 is the input. So we'll say the solution set is the set containing the number 3 and only the number 3. That's the only input that gets us to that output. Then I say h of x equals 9.1 for this second problem. And I look at the table and I see, okay, 9.1 is in that second row. And so the input that gets us to 9.1 is the number 0. So 0 is the input that gets us the output of 9.1. So 0 is the solution. The solution set is the set containing the number 0. And then part 3 here says solve h of x equals 0.258. And for this one, this is not a possible output for the function. Right, if we look down that second column, we have 2.8, 9.1, 0.1, negative 1.4, 9.5, or 9.4. And none of those are 0.258. So we say here that there are no solutions, and the solution set is empty. I just realized I haven't talked about domain in previous videos, so don't stress this. Now. So ignore for now, really. I mean, it's simply the domain is the set of all possible inputs that work for a function, so that's why I'm writing that. But we'll actually do a lesson on that here after next class. So module 2c goes into domain and range and what those are, and getting our heads wrapped around them. So sorry, I didn't mean to bring up something before we talked about it. All right, so that's it. That's the idea here of how to use a table to determine inputs and outputs given. So if you're given inputs and you're trying to find the outputs, that's evaluating, and so that's the part A here. And then if we're given outputs and looking for the input, that's called solving, and so that's part B of this problem. So hopefully that's pretty straightforward for you. Go ahead and do the now you try problem, run through that, and then in the next video I will run through the solutions of that with you. Thank you much. I'll see you in the next one.